You must have been introduced to this concept called Surds, and your teacher that introduced you to this concept must have told you that we both have rational and irrational numbers. And that teacher or that guider in the learning process must have told you that anything rational in terms of the numbers we have in mathematics must be able to get written in the form A over B. For example, someone can come up with a number or a decimal number like 0.2, and this can get rewritten as 2 over 10. And this can further be able to get simplified in such a way that our resultant answer must be 1 over 5. So this is a very good example of a rational number, and that number is 0.2. Someone can decide to actually give you a number like 25. This is also rational. Why? It can get written as 25 over 1. Someone can actually come up with a number like root 16. This is also a rational number. Why? Because it can actually be able to get translated into 4, and which can further be able to get written as 4 over 1, making it to become rational. So anything rational must be able to get written as a fraction. And in most cases, decimal numbers which are not recurring are rational. For example, 0.625 is rational. Why? It can get written as 625 over 1000. And this can further get simplified to give us a number or to give us a form which is A over B. And this is 5 over 8. So it makes this decimal number 0.625 to become rational. And on the other hand, if someone talks about irrational numbers, we can have an example like root 2. This translates into a recurring number that cannot get written as a number with this format A over B. So most rational numbers are actually able to get written in the form A over B, and most irrational numbers are recurring decimal numbers that cannot get written in the form A over B. So beside that, I have a question here. The question says simplify this, leaving the answer in the form A plus B root C, where A, B and C are rational numbers. So the question is 3 over root 5 minus 2, then plus 1 over root 5. So with the concept of Surds, you can actually be able to find this in both the Pearson Edexcel curriculum, the Cambridge IGCSE, and the Kenyan Certificate of Secondary Education. And of course, the concept has to actually have the same way in which the question can get done for us to get the final answer. So if told to simplify this, sometimes I can tell you rationalize the denominator, or simplify, or work out and write your answer in the simplest form. And of course, you've been told to write your answer in the form A plus B root C, where A, B, and C are rational numbers. So to mean they can get it in the form A over B. So let's start. We can be able to first work out this part and be able to work out this other part, then finally combine them and get the resultant answer. So how do I rationalize this denominator here and further come up with a way in which I can rationalize this denominator for me to get the final answer? This is what I'm going to have. I'll write down this 3 over root 5 minus 2. Then what do? I actually multiply on both sides with a conjugate, and that means I'm going to only change the sign in as far as what I have on the denominator side of my question is concerned. So I get the conjugate of that. Very good. So rationalizing the denominator means you have to actually get a conjugate of what you have on the lower side of your fraction or the A over B given in the question, and be able to see how you can be able to finalize your working in terms of rationalizing that denominator. So we shall begin opening the brackets. 3 times root 5 that gives us 3 root 5. If this is just a numeral and this is a numeral under root, they are not like terms. So the only way we can be able to multiply them is to combine them directly without multiplying those numerals. Then we can have plus 3 times 2, that gives us 6. Then we shall say over. Now you have root 5 minus 2, then root 5 plus 2. So what you do for you to get the final answer for that, you're going to actually have this sort. You'll say a plus b and then a minus b. These two are the same. The only difference is the sign. So how do we work out this part? We shall actually be able to come up with this concept that actually gets extracted from what you call the quadratic entities. And this can result into a squared minus b squared. So in other words, I'll just come here and then pick the one that has a minus. Square those two parts, then be able to get the difference. So I'll say root 5 squared minus, okay, 2 squared. Yeah, so a squared minus b squared. So this is a and this is b. So I just say a, then I square, then b, then I square. I'll be able to get the answer. So I'll have 3 root 5 plus 6 over 5 squared, 25. The square root of 25, that gives us 5 minus 2 squared, 4. So our final answer for that part becomes 3 root 5 plus 6 over 1. So finally, we are going to have this as our answer for that part. So we are going to have 3 root 5 plus 6 because anything divided by 1 remains the same thing. Okay, let's take ourselves to this second part. Let's rationalize this second part. So we have 1 over root 5. How do we rationalize? By root 5 by root 5. There is nothing like getting a conjugate of this because it is only one part of that denominator. So we have 1 times root 5, that gives us root 5 over root 5 times root 5, that is root 25. The square root of 25, that gives us 5. Okay, so you're supposed to take this and then plus this because the sign between them is positive. So we shall have this 3 root 5 plus 6, then plus, of course, this is what we have as our answer for the first part. Then plus root 5 over 5. We shall say let this one be over 1. The LCM of 1 and 5 is 5 because we are actually going to treat them as fractions. Then later on we shall actually have this. We shall have 1 into 5, that is 5. So we shall say 5 into 3 root 5, then plus 6, then plus 5 into 5, 1, so 1 into root 5. So this is 15 root 5. I told you when you're actually opening the brackets or doing what you call multiplication, ensure that if they are not like terms, only pick those which are numerals, not under the root, and multiply them. Whatever is under a root must not be multiplied by whatever is not under a root. So we shall proceed and have, okay, plus 3 times 5, 15. So 5 times 6, that is 30. Okay, and then plus 1 times root 5, that gives us root 5. Okay, that is correct. So you're supposed to multiply this with this. That is correct. Okay, so we shall say this is over 5. So we shall have this. We shall treat this as 1. Okay, so we shall collect like terms so that you can be able to get the final answer. We shall have 15 root 5, this one here, plus 1 root 5, that gives us 16 root 5. Then plus 30, that does not have a companion, then this is divided by 5. To further simplify this, you can be able to actually divide all through by 5. So 5 there once, 5 into 16, that is 3.2. Okay, then plus 5 there once, 5 into 30, that is 6. So we shall have root 5, then 6. Finally, our answer is, we can rearrange that, so we can be able to have 6 plus 3 root 2. Okay, then we can be able to have this as our decimal. So we're going to have 6 plus 3.2 root 5 is our final answer. So that in this case, as per the demands of the question, we're going to have A as 6, B as 3.2, and C as 5. And they are all rational numbers.